Hello all, good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Differential Equations and Transforms, and now we are on to the topic of Laplace Transforms. In the previous classes, we have learned the initial value theorem and the final value theorem and how to proceed with the problem. With all the conditions mentioned here, we have processed with the problem, and now we are moving on to the RHS part of this particular problem, wherein we are verifying the initial value theorem. So what is your RHS? RHS is limit s tends to infinity s into f of s. What is that? Limit s tends to infinity s into f of s. We have already found what is f of s in the previous step. So limit s tends to infinity s into, what is capital F of s here? A by s plus b. So this will be written as a by s plus b here. So what we have done for this limit here in the previous LHS, we have just substituted the value of t in the function inside the limit. So that is what we are going to do here also. We are going to substitute the value of s as infinity in the function inside the limit. So what we will have, this s will be replaced by infinity and this s will be replaced by infinity, so that you will have infinity divided by infinity. So if we have a form like this, we cannot differentiate or we cannot proceed with the problem. So what is this form called? This form is called as infinity by infinity form. What is the obvious case of applying or proceeding with the problem? We have to apply or use this L'Hopital's rule. What we have to do? We have to use or apply the L'Hopital rule. What has been given in the L'Hopital rule? If the limit, on applying the limit, it has been transformed into a form which is undefinable or undefined, we have to differentiate the numerator separately and denominator separately, and just you have to replace inside the limit place. That is what the rule says. What is the rule says? The rule says to differentiate the numerator separately with respect to the variable s and the denominator separately with respect to the variable s, and just to replace the numerator and the denominator. So what you will have in the RHS, you have s into a. So on differentiating s into a, you will have, on differentiating s into a with respect to s, you will have a alone. So this we have learnt already, and that is why we have replaced the numerator as a. And what do we have in the denominator? We have s plus b. We have s plus b. Now what is the differentiation of s by s plus b? On differentiating s, it is 1. On differentiating b, it is already I have said you, a and b are constants. So on differentiating the constant, you will have 0. So the denominator will become 1. And that is why we have replaced the denominator as 1. I will repeat it once again. Since it is in the form of infinity by infinity, we are applying the L'Hopital's rule, and therefore we should differentiate the numerator separately and replace the numerator, and differentiate the denominator separately and replace the denominator thing there. Therefore, you will have s into a on differentiating a there, and s plus b on differentiating 1 here. So now we will apply this s to infinity. Do we have any s here? No, we do not have any s. So that's it, the limit have been vanished here. The only value remaining inside the limit here is a. So what is your RHS? RHS is equal to a. From the first equation where your LHS have been replaced with a and RHS we have found as a, from 1 and 2 we can notice that the initial value theorem is verified. So how have we verified this? We have verified just using the theorem statement. What is the statement given here? F of t and f dash of t exist. So we have given with the f of t, that is existing, and we have found the derivative, that is also existing. And we have moved on to the next case. This is L of f of t, which is equal to f of s. And we have verified that f of s is also existing. F of s is equal to a into 1 by s plus b. Now we will move on to the LHS. LHS we have just taken it up and substituted the limit and found the value as A. RHS we have taken it up and substituted the limit as S tends to infinity. Since it has been coming into infinity by infinity form, we have used the L'Hopital's rule and we have resubstituted the limit and found the value of RHS. And you notice that LHS and RHS are same and therefore the initial value theorem is verified. So we will do the next problem in the next video. Thank you.